So, welcome to this lecture. In the last lecture, we have discussed the permutation, means we have to find the permutations of objects or elements if that objects or elements are repeated. Yes. Also, we have discussed two theorems or two results on a permutation with repetition is allowed. If the permutations with repetition is allowed, then the total number of permutation is given by n raised to r. So this is the theorem or a result we have discussed in the last lecture. And the next result is, if there are n distinct elements, out of these n distinct elements, p elements are alike of first kind, q elements are alike of second kind, and the remaining elements are n minus p minus q elements are of different kinds, then the total number of permutations with repetition is allowed is given by n factorial upon p factorial into q factorial. Yes. So now we will here solve some examples on such results or such cases. Yes. So let us see here. First example, when the repetition is allowed. So let us see, what is the number of ways to order the digits 1, 1, 2, 2, 2, 3 such that the condition is, under the condition, no digit is repeated. Second one is, the digits may be repeated. Yes. So here the set is given with one digit is repeated twice, two digit is repeated thrice, and three digit is distinct. Yes. And we have to find out the permutation under no digit is repeated and the digit may be repeated. So how we can solve this example? So let us see. No digit is repeated, it means that the total number of digits is n is equals to 6. We cannot repeat the digits. Already the digits are given 1, 1, 2, 2, 2 and 3. Yes. Out of which the digit 1 appears twice, the digit 2 appears thrice. Yes. So you can denote p is equals to 2 and q is equals to 3. Are you understand? Yes. And by using the formula to find the permutations with repeated element is equals to n factorial upon p factorial into q factorial. And just you can calculate, we get there are 60 distinct permutations of the digit 1, 1, 2, 2, 2 and 3. Yes. So let us see now the second condition, the digit may be repeated. So under this condition, if the repetition of digit is allowed, we are considering all possible 6 digit sequences with each digit can be any one of the that given set, since the position are filled independently. Yes. And each position can be filled by any of these 6 digits. So the number of ways equals to 6 raised to 6. So are you got how we can calculate it is 6 raised to 6? Because we have to select 6 digits out of these 6 digits. That's why it is n raised to r. R is also 6 and n is also 6. That's why it is 6 raised to 6, means 46,656 is the total number of permutations of 6 elements taken at 6 times with repetition is allowed. Yes. Now let us see here the next example. What is the number of ways to order the digits 1, 2, 0, 3, 4, 7 and 9 such that 5 digits numbers can be formed when repetition of digit is not allowed? So we have to find out here, or we have to order the given digits such that the 5 digits numbers can be formed when the repetition of digit is not allowed here. So how we can form the 5 digit number? So here there are total, how many digits are given? Yes, 7. So the number of digit is 7 and the repetition of digit are not allowed here. So we have to form the 5 digit number. So the digit 0 is not placed in 10,000 place. Why? Because if you take that in 10,000 place, then the given number is not a 5 digit number. Are you got my point? Yes. So that's why out of these 7 digits, only 6 digits are only on a first position. Yes, why? Because 0 cannot be in the leading digit. Yes, after choosing this first digit, we have 6 remaining digits including 0. So we need to select 4 out of 6 digits and arrange them. Hence, the number of ways to choose and arrange these 4 out of 6 remaining digit is given by 6 P4 ways. So the total number of permutation is 6 times into 6 P4. Yes, are you understand how we can calculate this? And just you can calculate this by applying the definition of permutation, and hence the total number of permutation is given by 6 into 360, which is equals to 2160. Therefore, the total number of permutations to form 5-digit numbers without repetition of digit is 2160. Yes. So, are you understand? Yes. Now look at here. The next example. How many different words can be formed with the letters of the word mathematics? So we have to find out the permutation of the letters which are in the word mathematics. So how many number of letters are in this word mathematics? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. So there are 11 letters which are included in the word mathematics. Yes. So after that you can check how many letters are of alike one kind. Yes. So let us see. These are the letters. These are 11 letters, and M, A and T, all these letters are appear twice. Yes. So that's why we can denote P is equals to 2 for M is repeated twice. After that Q is equals to 2. A is also, that letter is alike of second kind, and you can denote R is equals to 2 for the T letter which is appear twice. Yes. So we use the formula for permutation with repeated elements is the total number of permutations is equals to n factorial upon p factorial into q factorial into r factorial. So by substituting these values, we get the total number of permutations is equals to 11 factorial divided by 2 factorial into 2 factorial into 2 factorial. Yes. Now we can calculate the factorial. Just you can calculate 11 factorial and then 2 factorial, and you can divide it. We get the answer. There are 4989600 distinct permutations of the letter of the word mathematics. Yes. So let us see here the next example. How many words can be formed with the letters of the word equation? Under the condition vowels are always together, vowels occupy only odd number position. Yes. So these are the two conditions. Under these two conditions, we have to find out the total number of permutations of the letters of the word equation. So first you can check whether the letters are appear twice or thrice, and then you can apply the definition of permutation under the condition, under the given conditions. So if we see, there are 8 letters in the word equation. Out of these 8 letters, 5 letters are vowels and 3 are consonants. So vowels are always together. So we treat these 5 vowels as a single unit because that condition is we have to take that always together. And when we consider the remaining 3 letters as a 3 separate units, so what are the total number of units are there? 4. So therefore to arrange the number of ways to arrange these 4 units is in 4 factorial ways. Also within the single vowel, there are 5 vowels can be arranged in 5 factorial ways. Hence the total number of ways to arrange these letters with all vowels together is given by applying the multiplication principle. We get 4 factorial into 5 factorial is equals to 24 the 120 and equals to 2880. Yes. So see here the second condition. vowels occupy only odd number position. So here the condition is the vowel is in the odd number position. So in the word equation there are 8 letters. Out of these 8 letters, what are the odd positions? 1, 3, 5 and 7. So these are the 4 odd positions. Yes, out of 8 letters, 8 positions. Since we have 5 vowels, we need to assign these vowels where? To the odd position, ensuring that no repetition of these positions are given. We have to check. Hence, the number of ways to choose and arrange these 4 out of 5 vowels in 4 odd position is 5p4 ways. Yes, and just you can calculate. After the placing of these vowels, we have 4 position left. What are those? All these are even position. So which include 1 remaining vowel and 3 consonants. So you can place 1 remaining vowel and 3 consonant on these remaining 4 position. Therefore, the total number of ways to arrange the letters with vowel occupying only odd number position is given by 5p4 into 4 factorial. We get this thing. We get the desired result 2880. Yes. So let us see here the next example. Just a minute. The examination of 5 students can be conducted, out of which 2 students take the examination in physics and the remaining students can appear for the examination in different subjects. In how many ways can we arrange the students seated in a row? Then the first condition is examinees of physics sit together. Yes. The second one is examinees of physics do not sit together. And the third position is, or third condition is, examinees of physics sit in even numbered position. Yes. So under this condition we have to find out the permutation. So let us see, the first condition is examinees of physics sit together. And if you read this carefully, there are 5 students are there. So hence these can be sit in 5 factorial ways. And now the physics sit together, it means that we can treat the 2 examinees of physics as a single unit. Yes. So we have 4 units to be arranged. Are you understand? The single unit of 2 physics students plus the remaining 3 students. So therefore, the number of ways to arrange these 4 units is 4 factorial ways. And within the single unit, the 2 physics students can be arranged in 2 factorial ways. Hence, the total number of permutations where the physics students sit together is given by the multiplication principle, and it is 48 ways you can sit the examinees of physics sit together. Yes. Now see here the solution when the examinees of physics do not sit together. Since now this question is opposite to the previous one. Since the total number of ways the examinees can sit in 5 factorial ways, it is obvious. After that, if you calculate the number of ways the physics students sit together is already we can calculate in the first condition, it is the 48 ways. Then you can subtract this number of student number of examinees of physics sit together from the total number of ways of examinees. Yes. So that's why it is 5 factorial minus 48. We get 120 minus 48 is equals to 72 ways. It means that there are 72 ways the examinees of physics do not sit together. Yes. So this is the permutation. And now see here the third one. Examinees of physics sit in even numbered position. So now we have to sit that examinee in even numbered position. So there are 5 positions to sit examinees in a row. So the position 1 to 5 with position 2 and 4 being even. Yes, because already there are 5 positions. Out of these 5 positions, 2 and 4 is even position, and that we have to fix for examinees for physics. Yes. So the remaining 3 students can be arranged in a remaining 3 positions in 3 factorial ways. Therefore, the total number of permutations where the physics students sit in the even numbered position is given by 12 ways. So, are you understand this one? Yes. Now we will summarize this lecture. So, what is the summary? The first we will see how to find the total number of permutations of the order of the digit where no digit is repeated and digit may be repeated. Second one, we will discuss how to find the number of ways of the order of the digit in a particular set when 5 digit numbers can be formed when the repetition of digit is not allowed. Third example, we have solved for total number of permutations of the word can be formed with the letters of the word mathematics, and after that we will see the next example, or we have solved that example on the letter of the word equation under the condition of vowels are together and occupy only odd number of position, and next condition is we have to solve that example on how we can arrange the students seated in the row with different sitting position. So these are the some examples we have solved, whether on the different conditions, whether the elements are repeated or elements are not repeated, or that position is or even number position or odd number position. Yes. So today we will stop here.